Something in deep space was sending us a message every 16 days, without fail, for months. Then one day, it just stopped. By the end of this video, you'll know exactly what scientists found, why it terrified and thrilled them in equal measure, and why the answer they landed on might be even stranger than the question. It's January 2020. A team of astronomers is sifting through data from the Chime telescope in British Columbia, one of the most sensitive radio observatories ever built. And buried inside that data, they find something that stops them cold. A fast radio burst. An FRB. Now, if you haven't heard of fast radio bursts, here's what you need to know. They are among the most violent, energetic events in the known universe. In a single millisecond, a fast radio burst can release more energy than our sun produces in 3 days. In 1 millisecond. Most of them are one and done. A single flash from some unknown source billions of light years away, and then silence. We detect it, we log it, we have almost no idea what caused it. That's already unsettling enough. But this one was different. The signal, catalogued as FRB 201211102A, though you might know it better as FRB 180916, wasn't firing once and disappearing. It was repeating. And not randomly. Every 16.35 days, like clockwork, it would go active for roughly 4 days, blasting bursts into the cosmos, and then go completely silent for 12 days. Then come back. Active for 4 days. Silent for 12. Over and over. 4 months. No fast radio burst had ever done this before. Not once. In the entire history of radio astronomy, this was a first. Let's sit with this for a moment. Because the precision here is the part that should unsettle you. This isn't approximate. It isn't roughly every 2 weeks. Scientists measured the cycle down to a fraction of a day. 16.35 days. Repeating. Cycling. Predictable. And the source? 500 million light-years away. In a galaxy called SDSS J015800.28 plus 654253.0. A galaxy that, from our perspective, is little more than a smudge of ancient light. 500 million light-years. The signal you're watching on those telescope readouts left its source when complex multicellular life was just beginning to diversify on Earth. It crossed the void for 500 million years. And when it finally arrived at our little blue dot, it arrived on schedule. That number, 16.35 days, became an obsession for astronomers around the world. Because in science, when something repeats with that kind of precision, it usually means something is orbiting something. Or rotating. Or doing something mechanical. Something structured. And that word structured is where things get philosophically dangerous. So what causes a fast radio burst to pulse on a 16-day cycle? Scientists got to work. And the hypotheses that emerged ranged from the mundane to the mind-bending. The first theory, a precessing neutron star. A neutron star, the ultradense collapsed core of a dead massive star, spinning and wobbling on its axis in such a way that its radio beam sweeps past Earth at regular intervals. Like a cosmic lighthouse. Every 16.35 days, the beam crosses our line of sight. Then it rotates away. It's elegant. It's physics-based. It's the kind of answer that fits neatly into textbooks. The second theory, a binary system. The FRB source orbits a companion star. Every 16.35 days, the companion stellar winds or the geometry of the orbit either blocks the signal or distorts it enough to cut transmission. The signal doesn't stop. We just stop being able to see it. Both theories are reasonable. Both have supporting evidence. Both leave enormous open questions. But here's what they didn't tell you in the headlines. There was a third category of hypothesis that scientists discussed quietly, carefully, and with the appropriate academic caution that had nothing to do with dying stars or orbital mechanics. But before we get to that, you need to understand something even stranger about the signal itself. Here's what got buried in the science papers. The bursts within each 4-day active window weren't random either. They drifted. Subpulses within the burst structure showed a pattern of frequency drift, a consistent downward slide in radio frequency, sometimes called the sad trombone pattern by researchers. That drift suggested the bursts weren't simply a beam sweeping past us. Something was modulating the signal, shaping it. The source wasn't just repeating, it was varying internally in ways that hinted at structure within structure. A pattern inside a pattern. And then, in late 2020, the signal went quiet. The cycle broke. FRB 180916 went dark, and the 16.35-day rhythm that had been so achingly precise simply stopped showing up. So what is FRB 180916? Really? The scientific consensus, and this is the actual, published, peer-reviewed answer, leans toward a magnetar. A magnetar is a neutron star with a magnetic field so incomprehensibly powerful it would strip the iron from your blood cells if you got within 1,000 kilometers of it. In 2020, our own Milky Way produced its first confirmed magnetar-sourced fast radio burst, from a source called SGR 1935 plus 2154. Proof that these objects can create FRBs. The leading model for FRB 180,916 16.35 day cycle is that the magnetar exists in a binary system, orbiting a massive companion star, likely a B-type star, surrounded by a disk of gas. As the magnetar orbits, its radio bursts must pass through varying densities of stellar wind and gas. For about 4 days per orbit, the geometry aligns. We see the bursts. For 12 days, the gas clouds the signal, or the geometry rotates away, and silence. The precision of 16.35 days isn't mystical. It's orbital mechanics. It's gravity doing what gravity has always done, across 500 million light-years of cold dark space. But here's the thing that still keeps radio astronomers up at night. We don't know why it stopped. The orbit didn't change. The physics didn't break. The signal simply ceased. And we are still waiting. Here's the bigger picture. And it's important. We have detected over 1,000 fast radio bursts. Of those, only a handful repeat. And of those that repeat, only a tiny number show any periodic structure at all. FRB 180916 is, as of now, one of the most precisely periodic fast radio bursts ever recorded in human history. That means every time we try to understand it, we're not just solving one puzzle. We're building the vocabulary for a language we barely speak yet. The language of the violent, ancient, magnetic universe. Every burst we decode teaches us something about matter under conditions so extreme they don't exist anywhere near our solar system. Conditions where the laws of physics are pushed to their absolute limits. And somewhere, 500 million light-years away, a dead star, or something orbiting one, is still spinning. Still cycling. Still waiting for the geometry to align again. The signal may return. And when it does, we'll be listening. If this broke your brain a little, good. Subscribe. We drop one of these every week. Next time, there's a star at the center of our galaxy that shouldn't exist. It's older than the Milky Way itself. And astronomers have no idea how it got there.